Captain Crash and the Beauty Queen from Mars. Are you ready? Then let's do this.
It's time for Maths with Mr. Thomas.
Welcome to Chapter 7. This is lesson number 11. Ooh, it's like a little poem. Here we go with the first lesson on bearings. I have split bearings across 2 lessons because it's the one thing that lots of people ask at study supports and so on. To make this dead easy, I've split it into bite-sized chunks. I have got this first lesson here on bearings without any trigonometry. So if you are given some angles, you then have to work out other angles. That is what lots of people struggle with when it comes to bearings. So check that you can perfect these questions before you move on. You need to be an absolute expert on just working out the angles without any trigonometry before you apply the trigonometry to the questions. So check that you can do these before you move on to the next lesson. The lesson after this is when we do the same thing, but we then bring trigonometry in to answer the questions. So we're going to start off just with a quick recap on bearings. Jamie, what are bearings?
They're things used by pilots and boat steering people to give directions.
They are indeed, yes, Jamie, you are perfectly right. They are used by pilots and sailors to describe the direction in which they are travelling. There are things that you need to remember about bearings. Sarah, give me one thing about bearings.
Bearings are always measured from north.
They are indeed, yes, they're always measured from north. Something else, Lewis.
They're always measured in a clockwise direction.
They are, yes, they're always measured in a clockwise direction. They're always measured from north, coming round in a clockwise direction. You are perfectly right. Good. And the final thing, what else do you need to know about them? Spider-Man, can you tell us?
They're 3 figures.
They are 3 figures, yes. So, for example, if you had an angle of 60 degrees, go on, Spidey, what would that be?
That would be 060.
It would indeed, yes. Rather than just 60 degrees, you would have 060. There are 3 figures. 1, 2, 3. Wow. That is what you would have. When they are drawn, you will have seen something like this already. You can see there is a point. That is where your boat or your plane or whatever is going to be. You've got the north line drawn in. You always need the north line when you're dealing with bearings. You will have this line drawn in, which shows the direction of travel. This is the direction the boat or the plane or whatever is travelling. And you can see here the size of the angle. Again, it's measured in a clockwise direction. So that is 120 degrees. Let's move on then. Something else that you need to know before we move on to the actual bearings questions is everything about angles. Think back to the likes of first year, second year, or even primary school. Right angles. What do we know about right angles, Alan?
They're 90 degrees.
They are indeed, yes, right angles are 90 degrees. They look something like this. And you can see this angle here is 60 degrees. This angle here is 30 degrees. But if you were given one of them and not the other, you could work it out. You could work out this angle here by doing 90 take away 30. It gives you the 60 and so on. So you need to be able to work out angles that form 90 degrees. Straight angles. What do we know about straight angles? Jeannie. Yeah, well done. They are 180 degrees. They're basically just a straight line. Good. So this angle here is 80 degrees. This angle here is 100 degrees. And again, if you didn't know this one, you could work out the size of it by doing 180, take away the 80. And it would give you the 100. Good. Vertically opposite angles. What are vertically opposite angles? Joy. Yeah, good. Vertically opposite angles is when you get 2 straight lines that cross and the angles opposite each other. So this angle is opposite this angle. And what do you know about those angles? They're the same! They are the same, yes. Vertically opposite angles are equal. Angles are opposite each other when 2 straight lines cross are the same. So this angle here is 50 degrees, this angle here is 50 degrees. If this is 130, this is also 130. And you can check you're right, because if you add them all together, you end up with 360. You do indeed, yes, and it's 360 degrees in a complete turn. Alternate angles. Some people call them zangles. It's when you have 2 parallel lines and you've got a line between them, and that forms a Z shape. And the angle that is here is the same as the opposite side, this angle just in here. So always look for Z shapes. a lot of the time when you're dealing with the bearings chapter, because you've got north lines drawn in, you may have a north line and that will be 73 degrees. You might have another north/south line drawn in, so always have a wee look for that. You'll see that when it comes to the examples. And finally, corresponding angles. Again, some people call them fangles. Fangles and zangles. It's weird, but it works. That, once again, is when you have parallel lines. There's two parallel lines. If you extend them, they're not getting closer together. They're not getting further apart. But the angle that is in this part of the F shape is the exact same as the angle that is in this part of the F shape. So always have a look for F shapes as well. A wee random bit thrown in here. Bethany, how would you work out the size of this little angle here?
Oh, that's easy. You just do 180, take away 122.
Fast talking Bethany, you're right. Why do you do that?
Because that's a straight line right there. Draw it.
Oh, like that, Bethany. Yes, you're right.
That's 180, so if you do 180, take away 122, you'll get the size of that angle there.
Well done, fast talking Bethany. High five.
Ow!
And let's move on now to look at some actual bearings questions then. So, example 1. Write down the bearing of A from B and B from A. Ba-ba-da-ba-dum-bum-bum. So, if we're given this shape here, you can see we have point B, we've got point A, and we've got our north line drawn in. Sometimes what I find easier is to extend the north line, extend it down to south as well. So if you're extending that there, obviously I'm trying to draw it with a mouse, it's not very neat. You can draw it a wee bit neater. The same with this one here as well. So from point A, also draw in a north line. So that line there will be facing north. And if you extend that to south as well. What you'll notice here is that we've got, if you turn it on its side, let me try that. If you turn it on its side, you'll notice that what letter of the alphabet do you have? Yeah, we've got our Z shape. You can see there is a Z shape there. Again, look for the Z shapes, because if you look for a Z shape, that angle is going to be the same as that one. You've also got the straight lines there. Straight line adds to 180 degrees. Let's put that back though and think about what we're wanting to work out first of all. So we want the bearing of A from B. Lots of people end up getting confused with this in the exam. But if that is from B, it means that is where you want to start. Imagine if we all got a Christmas card from Care. Where does that actual card start? Does it start with you or does it start with Care if you got it from Care?
Well, it starts at Care if it's going to be the one writing it, sending it.
Perfect, yes. It will be starting with Care. You're right, Ashley. So because the card will start at Care, that's where it's from, it means that is where you are starting. So we're starting then at B. And what we want to do is we want to find out the bearing of A. So from this point B, we want to work out the bearing here, going all the way up towards A. So, bearings are measured from north, so drawing the north line where you're starting. We're starting at B because that's where it's from. Again, a card from Care would be starting at Care. So, because we're wanting it from B, we're starting at B. Drawing the north line, look at the size of the angle, and the size of the angle is 56 degrees. It is 56 degrees, good. Would you just write 56 degrees?
No, it's 3-figure bearings. You'd write 056.
You would, yeah, you'd write 056 degrees, good. So that is what you would have. This time we're now wanting the bearing of B from A. So once again, because it's from A, that is where we're wanting to start. Again, our Christmas card from Care would be starting at Care. So a bearing from A, we're starting at point A. Let's change the colour. Let's go to blue. So we're wanting to start at this point here. The bearing is measured from north, so there's our north line. So we're looking for the size of this angle here from north all the way around to this line that's pointing down towards B. We're wanting the bearing of B from A. How could we go about doing that? What could we do? Can anybody help me out? Eric. Yeah, good. You know from north down to south is how many degrees? 180, good. That there would be 180 degrees, just from north all the way around to south. But we then need the size of this angle. How could we get the size of this angle?
Well, isn't that the same as 56? Because you've got the Z shape.
It is indeed, yeah. There's your Z shape there. There's a Z shape drawn in, so if this is 56 degrees, this angle here is also 56 degrees. Good. Which means if we're wanting to work out the size of the angle from A, so from A we've got 180 degrees to south, and then we're going 56 degrees past that. So what do we have to do? Yeah, we do the 56 degrees, add the 180 degrees, giving you an answer of, 236 degrees. Woo! And if you want that drawn slightly neater, that is what you would have. Well done. Do you want to try another one?
Yes, please.
Example 2, write down the bearing of C from D and D from C. Once again, thinking about that Christmas card from Care. Care, thank you very much. Merry Christmas. We have point C and point D. We are wanting, first of all, the bearing of C from D, and because our Christmas card from Care starts with Care, he's the one writing it and then posting it, that is where we would start. We would start with Care. So because here it's from D, we're starting at point D. Bearings are measured from north. There's our north line drawn in, and we want the size of this angle going from north around to this line that points towards C, because it's the bearing of C that we are wanting. The size of that angle then would be 132 degrees. You're right, well done, it's just 132. The bearing of D from C, that is when we are swapping this around. So because it's from C this time, we are starting at point C. So imagine standing there. Bearings are measured from north. So draw in your north line. There's your line that is facing north. And we're looking for the size of the angle that goes from north all the way around to this line that's pointing up towards D. So that is what we need to find. In order to do that, once again, I find these questions so much easier if you extend the north line to go to south as well, because if you do that, well, again, you're just forming that Z shape just on its side. You can see, where's the highlighter? You can see there is a Z shape. Kind of, it's a funny looking Z shape. Or you can do it the other way around as well. There again is your Z shape. It's the parallel lines made up with another line. But also, you can see that if you go from north all the way around to south, how many degrees is it from north to south? Yeah, you would turn through 180 degrees. So north to south is going to be 180, and it's the size of this angle that you then want to find. But what size is this angle? Does anybody know? Good, yeah, you're getting it perfectly right. If you turn that on its side, as I said, there is your Z shape. You can either think about the Z shape just like that, or if you do a funny looking Z shape, you've got it there. There's the top of the Z, the line that joins, and then the bottom. So that there is 132. That is also 132. If I just put that back. So it means then, this bit here is 132. So north to south is 180. You're adding on that 132. Working that out, 180 plus the 132 gives you an answer of, 312 degrees. Woo! Well done. And again, if you want it drawn out a little neater, that is it there. Drawing in the north to south line, 180 plus that 132 because of the Z shape. Example 3, write down the bearing of E from F and F from E. So to begin with, again, what makes this easier, draw in your north to south line. There is north, heading down to south, and just extend that line there. To begin with, you're wanting the bearing of E from F, so because it's from F, that is where you want to start. So there is point F. Once again, a Christmas card from Care would be starting with Care, so that's where you would start. If it's from F, that's where you start. So from F, that's where we're starting. We're drawing in our north line and we're looking for the size of this angle. How do we go about getting the size of that angle? Good. What you can do, you know from here all the way around to here is 250 degrees. But you also know that this angle from north to south is 180 degrees. Which means how many degrees have you gone past 180 to get to that line?
When you do 250, take away 180.
You would, good, and that gives you 70 degrees. So that bit there is 70 degrees, and because you've got your Z shape, there is your Z shape just there, it means that if that's 70 degrees down here, it's also going to be 70 degrees just at the top, from north all the way around to that line there. So E from F will also be 70 degrees. Yay! And for the other bit, you want the bearing of F from E. So because it's from E, that's where you're starting. So imagine you're standing there at E and you're looking for the bearing from north all the way around to the line that points towards F. What do you think that is?
Isn't that just 250 degrees?
It is, Callum. Yes, it's 250 degrees. And slightly neater, you would have that there. Woo! Example 4, write down the bearing of G from H and H from G. There are your 2 points. There's point H, drawing a north line that heads down to south. There, it's going up towards north. And there's your north line there. Again, draw that down towards south. We want the bearing of G from H. So because it's from H, that is where you want to start. So we're starting there at H. And we want the bearing of G. So from north all the way around to that line that points down towards G. That's what you're wanting to find. How do you go about doing that? Good, yeah. If you look here, you're told that from north all the way around past south to here is 307 degrees, but you know that from north around to here isn't it 180? It is good. That there is 180 degrees. So how many degrees did you go past that in order to get to the 307?
Oh, you do the 307 take away 180.
Good, and you get
127.
Good, which means that angle there is 127 degrees. It is 127 degrees past 180 to get to that 307. And once again, if you put this just on its side, you will see that you've got a Z shape here. But if you draw it a slightly different way, you'll see that if you take this part and then jump across and then up, these are the two parallel lines, meaning this angle here of 127 is the same as this angle here of 127. So the size of this angle is the exact same as this one, meaning the bearing then is 127 degrees. And the bearing of H from G, because it's from G, imagine you're starting there at point G, and you want the bearing from north all the way around to the line that points up towards H. And that would be,
that's just 307.
It is, yes. Well done, Rebecca. It's 307 degrees. Woo! And once again, slightly neater. That is it there, drawn in.
Yay!
Notice as well, for this, I've done it a slightly different way. That's one way of doing it. I could also have worked out the size of this angle here, taking it away from a complete turn of 360. How many degrees do you add on to get to the 307? You're adding on 53. Again, a Z shape, that would also be the 53. And then take that away from 180 to get the 127. There's different ways of working this out. Again, think of everything you know about angles and then find some way of working it out. It's not just the one correct method. Sometimes there's a few. Let's move on though. Let's try the likes of this question here. So, example 5, fill out as many angles as you can. First of all, you'll see we have point A, we've got point B, and we've got point C. See, for every single one, you can see what I've done is I've extended the north line to go down towards south. I always find that slightly easier because then it gives you the parallel lines and you can start thinking about your F shapes or Z shapes. So, looking at this, filling out as many angles as you can. How do we do that? Somebody give me an angle.
Well, because you've got from north to south there at point A, if that's 110, and if that's 30, all three of those angles, padoink, 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 they would add to 180 because you're going from north to south. So do 180, take away 110, and take away the 30.
Shazeb, you're perfectly right. Good. And what does that give you?
40.
Well done. Yes, you know that angle there is going to be 40 degrees. Good. Any others?
Yes, I've got one. See how you've got the point there at C?
Yeah.
And we know that's 40 degrees just there.
Good.
Well, if you go down, then across, and then down, that gives you a Z shape.
It does indeed, yeah. You've got a Z shape right there. Down, then across, then down. Yes, good. You've got your Z shape. And George, what does that mean then? Yeah, it means that there is going to be 40 degrees as well. Good. So that would also be 40 degrees. What else do we know? Yeah, again, another Z shape. There's a south line there going up to A, then down, then up. Notice how these lines are parallel. That line is parallel with that one, which means if that's 30 degrees, that there would also be 30 degrees. Good. So that there is 30. What else? Good. There's a triangle. If you ignore everything outside of the triangle, we know that there is 40. We know this angle here, if we do the 30 add the 40, would be 70 degrees. And if you do 70 add 40, you end up with 110. Do the 180, take away 110, and it means this angle here is going to be 70 degrees. So you've got that angle just there. Look for angles inside the triangle. And finally, this angle at the top. How do you get that angle? Good. If you do the 70, add the 40, it's 110. Take that away from 180, and you'd also have the 70 degrees at the top there. Good. Or you could have gone down here, then across, then down, and that angle up here would be the same as this angle just here. So that is pretty much all the angles filled out, apart from these ones just at the bottom. But from north to south at 180, take away the 40, and it means that there's going to be 140 degrees. And there as well, from north round to south, so 180, take away the 30, and that there would be 150 degrees. Good. So you've got the size of those angles. Let's put that slightly neater though. So that is everything just there. Now let's try and get the bearing of these different ones. So we're wanting the bearing first of all of B from A. So because it's from A, we're going to be starting at A. So starting at point A, and we want the bearing of B. So from A, draw in the north line, come round from the north line to the line that points towards B, and that's an angle of, good, it's just 110 degrees. Brilliant, good. So we've got the first one. Next one, we're wanting the bearing of A from B. So because it's from B, that is where you would start. So we're starting there at B, and we want the bearing of A. So from north, you're coming around past south, past this line here, to this line here that points up towards A. How do you get the size of that angle? Good, you can do 180, north to south, add this 40, add this 70, and you get your answer of 390. Or, you know a complete turn's 360, so just take away the 70. Doesn't matter which way you're doing it, as long as you get the 290 degrees, as long as you're getting the correct answer. Next one, the bearing of B from C. Once again, because it's from C, that's where we're starting. So starting here down at C, you want the bearing of B. So from your north line, go round until you face B. So turn round until you're facing this line here. So you're facing towards B. The size of that angle is 40 degrees, but you would write it as 040. Good. Write it as 040 for 40 degrees. The bearing of C from B, once again, because it's from B, we're going to be starting at B. So starting here at B, we want the bearing of C. So from north all the way around until we hit the line that is facing C. So this angle here. It's just 180. Add on the 40, so we get an answer of 220. Good. The bearing of C from A. So from A, we're wanting to be starting at A. So we're starting there. And the bearing of C, so we're going from north all the way around to the line that goes towards C, which is this line here. Size of that angle, it is 110 degrees plus the 40. So we've got an answer of 150. And the bearing of A from C, because it's from C, that is where you're wanting to start. And face A. A is going up that way. So we're wanting from C, north line all the way around to that line just there. And that would be the 40 plus the 140, or you can imagine it's north to south 180, plus that 150. So you get an answer of 330. And yes, again, you could always do a 360 degree turn, take away that 30. Either way, you get 330 degrees. Woo! Let's try another one that's very similar to that one. What might be a good idea is to pause this video and check if you can work out the size of these angles. What might be a good idea is to pause this video, try to copy this out, fill out as many angles as you can, so see if you can work out the size of this angle, this angle, this angle, this angle, and the same with these angles, see if you can work them out, and then use that to try and answer these bearings. Pause the video now, see how you get on, and then unpause it when you want me to keep talking. So with these then, so you're wanting to fill out as many angles as you can. So first of all, this angle here is 108. This angle here is 33, but we know from north round to south is 180. Take away the 108 and take away the 33, and you get an answer of? Good, 39 degrees. Good, so you know that there is going to be 39 degrees. Other angles to fill out? Well, here there is a Z shape, going from this south line here up to this point, jump and then across to this point, and then going up to north. These north lines are all parallel. So because this angle here is 33, across from that, this small angle will also be 33 degrees. Good. You know from north round to south is 180, so if you do 180, take away the 133, you would end up with 147 degrees. And we also know that, again, north to south going this way is 180. Take away that 41 and you get an answer of 139 degrees. Good. Using that to work out these angles, well, because you've got a north line there, then jumping across and then down to south, you've got your Z shape just here. There is your Z shape. It's a backward Z, it's upside down, it's sideways. But you can use that to work out that because this is 41, this angle here is 41 degrees. Good. You know, obviously from north to south is 180, so you can get the size of that. And we also know that because this is your Z shape here, coming from north and then up and then down, that this angle here is going to be the same as these two angles added together. So if you add the 33 and the 39, you get 72. So we know that this angle here at the top will also be 72 degrees. 72 degrees. And finally, if this is 41 here and this is 72 here, if you add them together, take them away from 180, because from north to south is 180, take away the 72 and the 41, you get an answer here of 67 degrees. Woo! So that's you filling out all the angles. Slightly neater, or a lot neater, that would be your answer there, but you can now get the size of the angles. You can get the bearings. Once again, pause the video, try this yourself, write down 1 to 6 and see how you get on. Let's see how you did. So, the bearing of G from E, because it's from E, that's where you want to start. So we're starting at E, and we're going from north all the way around to this line that faces G. That bearing there will be 108 degrees. Another one, let's go from E from G. So because it's from G, we're starting at G, and you're wanting to go around to the line that faces E. So from north all the way around to this line here. This is the line that's facing up towards point E. To get the size of that angle, you could just do 180, add the 41, add on the 67, giving you an answer of 288. Or, what else could you do?
You can also do 360 and then take away that 72.
You could, yeah. You could also do the 360, take away the 72. You're perfectly right. Good. What else could you do instead of doing that? Yeah, you could also just have thought from north round to north is 360. Just take away that 72 degrees and it leaves you with this angle from here round to here. So 360, take away 72 will also give you 288. Let's try another one. So next one is the bearing of G from H. Because it's from H, that is where you're starting. So we're starting at 8 and you want the bearing of G. So from your north line right the way around, that there is going to be a bearing of 41 degrees. But you would write 041. Good, so you've got 041 degrees. The bearing of H from G, because it's from G, that is where you're going to be starting. So we're starting here at G, and the bearing of H, go from north all the way around to the line that is facing H, and that there would be a bearing of 180 plus the 41. So that's 221 degrees. The bearing of H from E, because it's from E, we're going to be starting at point E, and from north you're then going round to the line that is heading in the direction of H, which will be this line here. So it's the 108 degrees plus the 39 degrees, and if you add them together you will end up with 147. And finally, the bearing of E from H, because it's from H, that's where you start. So you start in there at H, draw in your north line, there's north line, and you go right the way around to the line that is heading off towards E, which means you do 41, add the 139, or again, the quick way of doing it, from north to south is 180. So do 180, add the 147, and you'll get an answer of 327 degrees. Or yes, once again, you know from north all the way around is 360, so just take away that 33, and again, you're left with 327 degrees. Woo! Hopefully you managed that one. How did you do? Yeah! Let's try another one. Example 7. First of all, fill out as many angles as you can in here, then state all those bearings. Once again, it's a good idea, pause the video, see how many angles you can fill out. Once you fill out as many angles as you can, the bearings part is so much easier. So pause the video, copy this down, see how many angles you can fill out. Good luck! Hey, welcome back. Thanks for the little break. So, filling out as many angles, well, let's start with the obvious. That there is 70, that there is 30, so this angle here 70 add 30 is 100. From north to south is 180, so we know this angle here is going to be 80 degrees. Woo! If we know this is 155, from north to south, again, I always extend the north lines to south as well, just to get that 180 degrees. Take away the 155 degrees, and you're left with... Good, you're left with 25 degrees. So you know this angle here is 25 degrees. What else do you know? Well, there is a north line. It jumps across to this point here and then down. So there's your Z shape. Because that's a Z shape, if this is 70, this will also be 70 degrees. Good. And because you've got a north to south line there of 180, that angle there is 180. Take away the 70, it means this bit here will be 110 degrees if you go from there around to here. So we've got all the angles around this point. That's obviously 180. We've got all the angles around this point, and filling out some here, look for your Z shapes. There is a Z shape right there. Point, up. There's a Z, so that angle is the same as that angle, which means that if that angle there is 25 degrees, this will also be 25 degrees as well. Good. So that there is the 25 degrees. Sorry, I'm trying to write with the mouse. It's not the easiest. Also, you've got a Z shape just here. So for this angle, there is a funny looking Z shape. There's a parallel length, a side, that's parallel with this north line. So this line and this line are parallel. They're joined up with this line. So you know that this angle is the same as this angle. And this one up here was the 70 plus that 30. Which means that there is 100 degrees. Good. And because that's 100 degrees, whoops, that looks like 6, it's 100. Because you've got this line, this angle at 100 and this angle at 25, add them together, take it away from 180, and it means this one here is going to be 55 degrees. Yeah! Well done. So that one there will be 55, because 180, take away the 100, take away the 25. And from north to south is obviously 180. So that is all the angles, and that is it a little neater. Now looking at the bearings. So for the bearings, we're wanting first of all the bearing of S from R. So first of all, where do we start?
Because it's R, we're starting at R, because that's where it's from.
Good, if it's from R, that's where you start. Let's keep mentioning this Christmas card from Care, because we get a Christmas card from Care that starts with Care. So because it's the bearing from R, we're starting at R. That is where we are starting. And then we're heading up towards S. We're heading up in that direction. Bearings are measured from north in a clockwise direction, so it's just the size of that angle, which is 70 degrees. But remember, it's 3 figure bearings, so you write 0, 7, 0. The bearing of R from S means we're going to be starting at S, so there is point S. And the bearing of R is going from north all the way around to that line that's in the direction of R. So it'll be that angle there. A couple of ways to do that. Either do 155, add 25, add 70, or north to south 180, add 70, or you could do a complete turns 360 and then take away the 110. Doesn't matter which way you do it, you get an answer of 250 degrees. Next one, if you want the bearing of T from S, we're going to be starting at S. There's S there. The bearing of T means from north all the way around to that line that is heading off towards T. That bearing there is obviously 155 degrees. Next one, the bearing of S from T, because it's from T, that's where you're starting. S from T means we're going from north all the way around to that line that is heading up towards S, which is just there. Again, a few ways to do it. You can do 180, add the 100, add the 155, will give you that angle, or a complete turns 360, just take away that 25 degrees. That gives you 335 degrees. The bearing of T from R, because it's from R, we're going to be starting at point R, drawing your north line, and then you're heading around to the line that goes towards T, which is this one here. So from north, we get 70 degrees plus the 30 degrees, giving you an answer of 100 degrees. And finally, the bearing of R from T, because it's from T, that is where you start. So we're starting at T, and from north, you're coming round till you are facing R. How do you do that? Well, it's just going to be 180 degrees to south, plus that 100 degrees, giving you an answer of 280 degrees. How did you get on with these ones? Hey, amazing! High five! 5 times. Yeah! Let's try another one. Again, this is just filling out as many angles as you can, working out the bearings. If you can do these, if you can perfect these, it'll make the lesson so much easier when it comes to bringing in trigonometry. So, let's begin. Filling out as many angles as you can. So, let's try and fill out this angle down here. How do you do that? Yeah, from north to south is 180. Take away that 69. Take away that 28 as well, and it leaves you with 83 degrees down here. Good, so you know that is 83 degrees. What else can you work out? Good, because you know that angle there is 137. From north to south is 180. It means if you take away 137 from 180, you will end up with 43 degrees. Good, just there. You've also got 69 just here, and that there is your Z shape. Always look for Z shapes. The north lines, north to south, are parallel. So because you've got the Z shape, if this is 69, this here will also be 69 degrees. Good. Different ways to work this one out. Complete turns 360, so you could take away the 137 and the 43 and the 69, leaving you with 111 degrees. Or again, you can look for your Z shape. There is a line going across to this line. These two lines are parallel. So if you do the 83 and the 28, that's the same as that 111. Getting these angles just in here, well, if this is 43 degrees, if you jump down to this point and then up, again, you're forming a Z shape. So this angle and this angle will be the same. So that there is going to be 43 degrees. Another Z shape, in order to get this angle down just in here, there is a line that is parallel with this line, and they are joined together. So if you do 69 add the 28, that gives you 97, which means the size of this angle in here will be 97 degrees. So that angle just there. And finally, from north round to south, whichever way you go is 180. So take away the 97, take away the 43, and you'd be left with this angle here at 40 degrees. Once again, slightly neater, that is what you would have. But because you can fill out all these angles, and this is what you can get the bearings. So, state the bearing of P from K first of all. So because it's from K, we are starting at K. There's K. The bearing of P means you're heading out towards P. So that bearing from north around there, it is 69 degrees. Good, which you'd write as 069. The bearing of K from P, so if it's from P, we're starting at P, and the bearing of K means from north all the way around to face K. Again, different ways to do that. You could do 137 add the 43, or 180 for north to south, add the 69, gives you an answer of 249 degrees, or 360 degrees right the way around, take away that 110, still gives you 249 degrees. Another one, L from P. If it's from P, that is where we are wanting to start. So we're starting here at point P, and we want to come down to this line that is just at L. That there, the bearing is going to be, 137 degrees. Good. The bearing of P from L means that's where we are standing, that's where we're starting, and we're turning around from north to face P. So we're coming right the way around here. Different ways to do that. Do 180, add 97, add the 40, or do 360, just take away that 43 degrees. Either way, gives you an answer of 317 degrees. And finally, the bearing of L from K. Because it's from K, that is where we start. We're starting there, we're facing north, and we're turning around to face point L. How do you work out the size of that angle? 69 add 28! Yes, indeed. If you do 69 add 28, you end up with 97 degrees. And the very, very last one, the bearing of K from L. If it's from L, that is where you're starting. So you're starting at L, and you're facing north, and you want to turn around to face K. That is K just up there. It's heading off in that direction. So that bearing there would be 180 plus 97. It is, which gives you 277 degrees. Woo! As I said, check that you can do these questions. Make sure that you're 100% okay with filling out all the angles and then calculating the bearings before trig is involved. If you are an expert with these, then move on to the trigonometry lesson. You'll find that so much easier if you are an expert with this first of all. There are some bearings worksheets. Have a look for them just on Teams, or there's various exercises in the different textbooks. But the ones that I put up on Teams are the best resource that I can find. Good luck. Enjoy. See you later. Have fun. Woo! High five for the bearings.